Welcome to this session on percentage. In this session, we will take a look at some questions based on expenditure, price, and quantity. So, what is the basic relation between expenditure, price, and quantity? We have expenditure is equal to price multiplied by quantity. So, we all know that many a times we encounter a situation where expenditure either has to be controlled or expenditure has to be maintained. And we also know that prices keep on rising. In such a case, one of the ways to control expenditure is to change the quantity that we buy. Say I increase the price has increased by X percent. By what percent should the quantity reduce so that the expenditure remains the same? Well, this session is all about identifying and trying to solve such questions. Let us say expenditure, which is equal to price into quantity, and let us say that the price increased by 50%. When the price increases by 50%, we need to find by what percent the quantity will reduce. So, to solve this question by a very basic method, we need to make some assumptions. And as I had told you in an earlier session, that when all the values are given in percentage in any question, you can do well by assuming something to be 100. In this case, because we are required to find the percentage change in quantity, I suggest you start by assuming the initial quantity Q as 100 and the initial price P is equal to 1 rupee per unit. So, what is the initial expenditure in this case? Initial expenditure will be 1, that is the price, multiplied by 100, that is equal to 100 rupees. Now, what happens to the new price? The new price increases by 50%, so it becomes 1 plus 50% of 1, that is equal to 1.5 rupees. So, because the price increases, there's going to be an obvious decline in the quantity that we purchase. But we have to keep the expenditure 100 rupees. So, 100 rupees is equal to price, the new price, that is 1.5, multiplied by the new consumption, that is Q1. So, what is the value of the new consumption? The new consumption can now be easily calculated as 66 2 by 3 units. So, how do you find the percentage by which the consumption has changed? In this case, the consumption has reduced. So, percentage reduction is given by the difference in the two quantities, that is 100 minus 66 integer 2 by 3, whole of this divided by, we are making a comparison with the old consumption or old quantity purchased, and therefore the denominator will be 100 into 100. This can also be represented by percentage change as new value minus old value upon old value into 100. This is the formula that we will often see in questions related to data interpretation, where NV stands for new value and OV stands for old value. So when you solve 100 minus 66 integer 2 by 3 upon 100 into 100, you will get a reduction of 33 integer 1 by 3%. Shortly, we will also solve the same question by another superior method by which we can get answers slightly faster. Let us see a question based on this particular concept. Let us solve it first by a basic method and then by our advanced method. So, what does the question tell you? The price of an item increased by 20%. By what percent should the consumption increase or decrease so that expenditure remains the same? This question is identical to the previous question. So, what we will do? We are asked to find the percentage change in consumption. So let us assume that the initial consumption Q1 is equal to 100 units. And let us also assume that initial price is 1 rupee per unit. So what is the initial expenditure? Initial expenditure is 1 multiplied by 100, that is 100 rupee. So because the initial expenditure is 100 rupees and this is not going to be changed, therefore the new expenditure E1 is also equal to 100 rupees, which must be equal to the new price. Now because price has increased by 20%, the new price P1 must be equal to P plus 20% of P, which must be equal to 1 plus 20% of 1, that is 1.2 rupees, multiplied by the new value of consumption. On solving this, we will get the value of consumption Q1 as 83 integer 1 by 3 units. What does this mean? The percentage change in consumption can be calculated as the original consumption minus the new consumption 83 1 by 3 units divided by the original consumption multiplied by 100. It's our standard formula. So this gives us 16 integer 2 by 3% as the answer. But this was our basic method, and we can also solve the same question by another slightly superior method of solving the question. So let us see that method also. We have expenditure is equal to price multiplied by quantity. And what do we have? We have the price going up by 20%. When the price goes up by 20%, we can say that the new value of price is equal to 1.2p or 120% of p. And 1.2p can be written in terms of fractions as 6 by 5p. If you simplify 1.2 as 12 by 10 and then reduce it, we will get 6 by 5 into p. So we can see that the price p increases by a factor of 6 upon 5. If the expenditure has to remain same, so the quantity must reduce by an amount that is equal to a multiplicative inverse of 6 by 5, that is, quantity must become 5 by 6 times itself. So what happens when quantity becomes 5 by 6 times itself? The new expenditure will still remain the same. It will be 6 by 5 into P multiplied by 5 by 6 into Q. Now 6 by 5 and 5 by 6, the product of these two fractions is 1. So the expenditure will remain the same as the old expenditure. But now let us focus our attention on consumption that we calculated. The new consumption calculated is 5/6 of the old consumption. So the reduction in consumption is equal to 1/6 of the old consumption. So once we calculate the reduction, we have the value of Q minus the new consumption. So this divided by old consumption multiplied by 100 will straight away give us the answer as 16 integer 2 by 3% reduction. So the consumption reduces by 16 2 by 3%. Another question, the price of oil reduced by 25%. By what percent can a man increase or decrease his consumption to keep the same expenditure? Once again, let us solve this question first by the basic method, and then we will take a look at the more superior and the quicker approach to solving this question. We already know that expenditure is equal to price multiplied by quantity, and we have our principle that if all the values, all the numeric values in a question are given in percentage, we assume something to be 100. So in this case, we have assumed the price to be 1 rupee and we have assumed the consumption to be 100 units. Why did we assume the consumption to be 100? Because we have been asked to find the increase or decrease in consumption. So let us calculate the initial expenditure. Initial expenditure is equal to price multiplied by quantity, that is 100, which is equal to 100 rupees. Now expenditure cannot change, it remains 100. So we write expenditure as 100 rupees. And what is the new price? The new price of oil has reduced by 25%. So instead of 1 rupee, which we assumed, we will have to have the price as 1 minus 25% of 1, which is equal to 0.75 rupees. So this basic calculation tells us that the new price is 0.75 and the new consumption is unknown, so we assume that to be Q1. So what is the value of Q1? 100 divided by 0.75, which is equal to 133 integer 1 by 3 units. Now what does that mean? That because the price is reduced, the consumption has increased to 133 integer 1 by 3 units. And what is this percentage increase given by? The percentage increase is given by the difference of the two consumptions, the new consumption and the old consumption in the numerator. That is 133 integer 1 by 3 minus 100 in the numerator, and this divided by 100 in the denominator. So what is the percentage increase? The percentage increase is equal to 33 integer 1 by 3%. So this is a basic method of solving the given question. Another method could be that if expenditure is equal to price into quantity, if price goes down by 25%, this means that price becomes 75% or 3/4. Mind you, 75% is equal to 75 by 100, which can be reduced to 3 by 4. So 3 by 4 times P. So if price becomes 3/4 of the initial price, for the expenditure to remain the same, quantity should become 4 by 3 times the initial quantity. That is when we will get the expenditure as equal to P into Q. So which means the new consumption is actually 4 by 3 times the old consumption. So what does this mean? This means that the new consumption minus the old consumption is 1/3 of the old consumption, and which stands for a 33 integer 1 by 3% of increase. Why 33 integer 1 by 3% increase? Because the percentage increase is given by the difference of new and old consumption. So 1 by 3Q divided by Q into 100, which will yield us the same figure, 33 integer 1 by 3%. So with this we come to an end of this session. In case you want to watch more videos, please log on to our website www.pfindia.com. You can mail your doubts to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.